Chapter 4.4, the quadratic formula. If we complete the square and solve for x on the general quadratic equation, ax squared plus bx plus c equals 0, we get the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's on your formula sheet. You do not need to memorize it. Example, solve 2x squared minus 3x plus 1 equals 0. So first we want to identify what is our a, b, and c. So a is in front of x squared, b is in front of x, and c is our constant term. The value in front of x squared is positive 2, so a equals 2. The value in front of x is negative 3, so b equals negative 3. And the constant term is positive 1, so c equals 1. Then I always write down just the quadratic formula without putting any of my numbers in first. So x equals negative b plus minus the square root of b squared minus 4ac divided by 2a. Then I plug in my numbers. So x equals, b is negative 3, so I have negative 3 plus or minus the square root b squared, so negative 3 in brackets squared. Make sure that it's in brackets because it's going to make a difference in your calculator. Minus 4 times a, which is 2, times c, which is 1. All divided by 2 times a, which is 2. Now I'm going to use my calculator. Negative 3 would be positive 3, so x equals 3 plus minus. I want to calculate what's under the square root. So bracket, negative 3, close bracket, squared, minus 4 times 2 times 1. I'm not square rooting, I'm just calculating what goes under the square root. So I get a 1 under the square root. And then on the bottom, I have 2 times 2, which is 4. 1 is a perfect square, so I can take the square root of that value. We get 3 plus or minus, square root of 1 is 1. Divided by 4. And then I can calculate the two cases I have if we are adding and if we are subtracting. So if we're adding, we get x equals 3 plus 1 divided by 4, which equals 4 divided by 4, and 4 divided by 4 is 1. If we're subtracting, we get x equals 3 minus 1 divided by 4, which is 2 divided by 4, which is 1/2. So our two solutions are x equals 1 and x equals 1/2. Example, solve x squared minus 5x plus 10 equals 0. Again, start by figuring out what is a, b, and c. So a is the value in front of x squared. That would be a positive 1 here. B is the value in front of x. That's a negative 5. And c is the constant term, which is positive 10. Then I write down the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Then I plug in my a, b, and c values. So x equals negative 5 plus minus the square root of bracket negative 5 close bracket squared minus 4 times 1 times c, which is 10, divided by 2 times a, which is 1. And then we start to simplify. Negative times negative 5 becomes positive 5. Plus minus, we want to calculate the square root. So bracket negative 5 close bracket squared minus 4 times 1, which we don't need to enter, and then times 10. That gives us negative 15. So the square root of negative 15, and then divided by 2 times 1 is 2. What do we notice here? We have the square root of a negative number. Can we take the square root of a negative number? No, we can't. So if we were to plug this into our calculator, fraction on the top, 5 plus square root of negative 15, and then on the bottom of the fraction, 2, and we get error. If we were to put a minus on the top, so 5 minus the square root of negative 15, all divided by 2, we get an error again, because we can't take the square root of a negative number. Can't square root a negative. This means that there is no solution. What does it mean there's no solution? Well, that means there's no x-intercept. And we saw what that looked like at the beginning of chapter 4. So let's see here, we have a y-intercept of 10. Our c value is 10, and we know the graph opens up because a is positive. So the parabola might look something like this, with the y-intercept at 10, and notice that we do not touch or cross the x-axis, so there are no x-intercepts, which means there's no solution, because the solutions to the quadratic equation are the x-intercepts of that quadratic function. If there are no x-intercepts, then there are no solutions. Notice we end up with no solution when the value under the square root is negative. Example, solve x squared plus 8x plus 16 equals 0. Let's figure out our a, b, and c values. A equals 1, we have 1x squared. B is 8, since we have positive 8x. And c, the constant term, is 16. Write down the quadratic formula. X equals negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Then plug in our a, b, and c values. X equals negative bracket 8 close bracket plus minus the square root of 8 in brackets squared minus 4 times a, which is 1, times c, which is 16, all divided by 2 times a, which is 1. Then we want to simplify. X equals negative times positive 8 is just negative 8, plus minus. Let's figure out what's under the square root. We have bracket 8 close bracket squared minus 4 times 1, we don't need to put, times 16. And we get 0. So negative 8 plus minus the square root of 0 divided by 2 times 1 is 2. The square root of 0 equals 0, so we get x equals -8 plus minus 0 divided by 2. And then we have two cases where we're either adding 0 or subtracting 0. But really, those are the same thing because adding 0 or subtracting 0 doesn't change the value. So we get x equals -8 divided by 2, which gives us x equals -4. Notice we only have one solution, and that's because the value under the square root equals 0, so the two different situations of adding or subtracting the square root are going to be the same. In the quadratic formula, the quantity under the radical sign b squared minus 4ac is called the discriminant. The discriminant in the quadratic formula determines the number of solutions and the type or nature of the roots. For b squared minus 4ac is greater than 0, so for a positive number under the square root, we get two real and distinct, which means different roots or solutions. So if the quadratic opens up, that might look like this, where we have two x-intercepts, 1, 2. If the discriminant is equal to 0, b squared minus 4ac equals 0. So if we have the square root of 0, then we're going to get two real and equal roots. Really, we just say that we have one root because the two real roots, they're the same. So two roots that are exactly the same, we can just say that it's one solution. So if it opens up, our quadratic might look like this. And if it opens down, it could look like this. And again, our root, as we saw in 4.1, if we have one solution or one x-intercept for a parabola, then it's going to be at the vertex. And then the third situation is where the discriminant b squared minus 4 times a times c is less than 0. So where we have the square root of a negative. In that situation, we have no real roots. So the parabola would have no x-intercepts. So if it's opening up, it might look like this. And if it's opening down, it might look like this. We never touch the x-axis, therefore we do not have any solution. For one solution, an example could be that when we factor, we get the same binomial. So x plus 5 times x plus 5, for example. Then we would have x equals -5 and x equals -5. So we have two roots, but they're both the same. So really we can just think of it as we have one solution. Example, use the discriminant to determine the nature and number of roots. We have x squared plus 8x plus 16 equals 0. So let's figure out the discriminant. Remember, the discriminant equals the part under the square root, which is b squared minus 4ac. In this case, a is 1, b is +8, and c is +16. Plug those into the discriminant, b squared, which is 8 squared, minus 4 times a, which is 1, times c, which is 16. Calculate that, which I think that's the last one we did. Yes. 8 squared minus 4 times 16. That was the last one that we did, and it equals 0. So what does that mean in terms of how many roots we have? Well, if your discriminant equals 0, then we have one solution, or 2 real and equal roots. So either way, you can write either I would accept 2 real and equal roots, or you could just say there is one real solution. We don't know what that solution is, we just know that there is one. Use the discriminant to determine the nature and number of roots for x squared minus 5x plus 10 equals 0. So same thing, the discriminant is b squared minus 4 times a times c. For this quadratic, a equals 1, b equals negative 5, and c equals 10. Then b squared minus 4 times a times c equals bracket negative 5 close bracket squared minus 4 times 1 times 10. Calculate that, bracket negative 5 close bracket squared minus 4 times 1, which we don't need, times 10, which is negative 15. When we have a negative number for the discriminant, that means we would have a negative under a square root, and we can't take the square root of a negative. So this means that we have no real solutions. Use the discriminant to determine the nature and number of roots for 2x squared minus 3x plus 1 equals 0. Here a equals 2, b equals negative 3, and c equals 1. The discriminant is b squared minus 4 times a times c. Plug in our values. B is negative 3, so bracket negative 3 close bracket squared minus 4 times a, which is 2, times c, which is 1. Calculate that, bracket negative 3 close bracket squared minus 4 times 2 times 1, we don't need, equals 1. Since we get a positive number for the discriminant, that means we have 2 real solutions. And just like with completing the square, we don't always end up with these perfect square values under our square root like we did here and here. So if we don't, then we simplify the square root as much as possible, just like we did in completing the square. Okay, so you can also write your answers as exact values with the quadratic formula by simplifying the radicals that aren't perfect squares and then simplifying the expression as much as possible. That brings us to the end of the Chapter 4 notes.